Alright, so now we're going to look at example 4. This is a long problem, meaning that it has multiple parts, but they're really all connected, so it doesn't take a long time to do. So let's do it together and get started. So the population of two countries are given for January 1st in 2000 and for January 1st in 2010. So 10 years difference. Part 1 says write a function of the form of p of t equal to p of 0 e to the kt power. To model each population p of t in millions after t years after January 1st, 2000. And we're going to do this for two different countries. So we're given Switzerland and Israel. And remember from previous problems we know that p of naught, where anything is of naught, it means the original amount. So what did we start with? Okay, so I'm going to do Switzerland in pink, and then I'm going to let you practice with Israel, and then we'll keep going from there. Okay, so Switzerland, we have that it was population in 2000 was 7.3, and then its population in 2010 is 7.8. So this 7.3 is our p naught value, and the 7.8 is our p of 10, because these are 10 years apart. Okay, and we're looking for our k value, okay, which happens to be our growth rate. You don't know that explicitly, but that's what it's called. So we're going to plug these numbers in. So we have 7.8 is equal to p naught, which is 7.3, e to k times t, so 10k. And we want to solve for k. So first, let's divide by 7.3 on both sides. Okay, so we have 7.8 divided by 7.3 is equal to e to the 10k. What do y'all think we're going to do next? Well, take the ln, of course. So we have 7.8 divided by 7.3 ln is equal to 10 times k. Or k is equal to the ln of 7.8, 7.3, all divided by 10. Using our calculator, we get that k is equal to 0.00662. I rounded this one way further out just because there weren't any numbers for that first 2 after the decimal. If you round it to 4, that's perfectly fine. Okay, so how does this help us find our function p of t for Switzerland? So we're going to take our k value and we're going to plug it into p of t, but we're not going to know what t is, so we're going to leave t out. So we get that our population function is p of t is equal to, well, our p naught still stays the same, it's 7.3 times e. Well, our k is now this long decimal place that we just found, so 0.00662 to the t power. So we found our population function. So this is just a function that estimates the population of Switzerland using the data we were given. Next, we're going to look at Israel. So if you want to practice this one on your own, feel free to solve it on your own and then come back to check your answer. I'm going to do this one quickly with not as much of an explanation. So again, this is our p of 10 and this is our p of naught. Plugging it into our formula, we get 7.7 equal to 6.7 e to the 10k. Taking the ln of both sides. Using our calculator, k is equal to 0.01391. So using our k value, we're going to find our p of t for Israel. So we have p of t is equal to, well, what was our original amount? 6.7 e to the 0.01391 t-value. And these two functions right here are our answer. That's what it was asking for. It said write a function of the form to model each population. Okay, next let's move on to part 2. And like before, these parts build on each other. Okay, so we're going to use the models from part 1 to approximate the population on January 1st of 2020 for each country. And we want to round to the nearest 100,000. So again, I'll start with Switzerland first, and I'll rewrite their population function that we found in part 1. So we had P of t was equal to 7.3 times e to the 0.00662 t value. So we want to find the population in January 1st of 2020. So we're going to find P of 20, because this is 20 years since the original date of January 1st in 2000. Okay, so we just plugged in 20 all the way into our equation, and then here we can use our calculator and solve. And we should get that it's 8.3 million. And this is Switzerland. Okay, next to find Israel's population, we're going to do the same thing. We're going to plug in 20 into its population function that we just found. So Israel's is P of t is equal to 6.7 e to the 0.01391 times t. So we're going to find P of 20. So we're going to plug in 20 every time we see a t in our function. And then we can use our calculator to simplify, and we get it as 8.8 million. And this is Israel. So we just used our model to find the population for both countries at a further date than what we were given. Okay, then looking at part 3, we see that Israel had fewer people than Switzerland in the year 2000, yet from our results in part 2, we see that Israel ends up with more people in the year 2020. Why is this? Okay, so it goes back to our functions that we found, our population functions. And we notice that our functions are in the similar form as what we've done for our continuous compounding investment problems, where it's some original value times e to the r times t. So what we found, our k value, is our growth rate. Okay, which one of them had a higher growth rate? Well, we see Switzerland was 0.00662. Whereas Israel's was 0.01391. So Israel had a greater growth rate. Again, 0.00662 is less than Israel's, which is 0.01391. And these are our growth rates. Okay? So because Israel's population is larger because of the growth rate. Then the last part asks us to predict when something would happen. So it says, use the model from part 1 to predict the year during which each population would reach 10 million if this trend continues. So we'll do Switzerland first. So we want the population to be 10 million. So that's what our P of T value would be. So 10 is equal to what? So we'll do Switzerland first. Remember their P of T is 7.3 e to the 0.00662 times t. And we want to solve for t. Like before, we're going to divide both sides by 7.3, and take the ln of both sides. So we have ln of 10 divided by 7.3 is equal to, the ln of e is 0.00662 times t. So we get that t is equal to the ln of 10 divided by 7.3 divided by 0.00662. So t is equal to 47.5. Now remember, t is the number of years since 2000. So if we add 47.5 to 2000, we would get that it happened sometime in the year of 2047. Okay, what about Israel's? So we're going to check it as well. So we want to set its population value equal to 10 as well. So we get 10 is equal to 6.7 e to the 0.01391 t, and solve for t. I'm going to skip a few steps because we've done it so many times and I think you're probably tired of hearing me say it. So we're taking the ln of 10, 6.7 is equal